We're on sample problem 2.11, and this one wants us to give the systematic name for each formula or the formula for each name for the following compounds. So A, I have something we haven't come to before in one of these sample problems. All right, we have iron, we have chlorine, and we have oxygen. But notice in parentheses here we have this ClO4, and it says I have two of those. That is indicative of a polyatomic ion. So if you look on page 68, table 2.5 of the textbook, you'll see the common polyatomic ions. And you're just going to have to memorize that table for the naming of these polyatomic ions. That's the best advice that I have for you. They're used a whole lot, and you'll start seeing them so much that you'll just remember the name of them. There's no way to kind of really look at that formula there to come up with a name. You really just have to memorize those from that table. So I have iron, and I have, if you look on the table, that is perchlorate. I don't know what the charge of iron is because it's one of the transition elements on the periodic table. But I do know the charge on the perchlorate ion from the table, and that is a -1. So let me go ahead and write that down. I've got iron, and I don't know what the charge is so far, and I've got the perchlorate. I'm going to write ClO4 with a minus charge. If that has a minus charge, and I have two of them, that must mean this whole thing right here has two negative. So then you ask yourself, what plus minus 2 is equal to 0? It's +2, so then the iron must have a 2+ charge. So now I can name this thing. The cation comes first, iron. Have to give it the Roman numeral 2 because it's a transition element and it has a 2+ charge. Perchlorate, that's the polyatomic ion. All right, B says I have sodium sulfite. Now, sulfite, again, that's going to be one of those polyatomic ions. This is not sulfide, right? It's not sulfur because that would get the IDE ending. This is sulfite. So it's going to be a polyatomic ion. If I look at that table, sulfite is SO3 with a 2- charge. So SO3. And from the periodic table, you know that sodium has a +1 charge, right? You can look there at the closest noble gas and figure out that it's got to gain and lose an electron, so it's going to have a +1 charge. So the formula for this guy then must be Na2SO3, right? I only need one of the sulfites because his has a -2 charge. I'm going to need two of the sodiums because it has a +1. 2 times the +1 would give me what I needed there. And I actually wrote the sulfite a little bit wrong there. That's supposed to be SO3, and I wrote a 2. So Na2SO3, sodium sulfite. The next one listed there, C, gives us the formula, so we are going to have to give it the name. So Ba, right, that's the symbol for barium. OH2, that's going to be a polyatomic ion. This OH, and if you look in the table, 2.5 on page 68, OH is a hydroxide ion. Okay, so and then also we have this little dot and 8 H2O. So I've got 8 of those H2Os, and remember H2O, that's water, right? We all know that H2O is water. Now, anytime it's in a formula like this, we call it a hydrate. Okay, so let's start naming this thing. We're going to have barium. It comes first because it's the cation, right? It has a +2 charge. You can figure that out from the periodic table. So I'm going to have barium hydroxide. And now I have to name those hydrates, and since I have 8 of them, I've got to add a prefix to that name. And so the prefix for 8 is octa. So octahydrate. And the prefix table is on page 69, and that's table 2.6. So you can look there to figure out where I found that prefix to represent the 8. So anytime you see this little dot in a formula, it's always going to have waters past it, and it's going to have some amount of waters. We call those hydrates, and then the prefix is going to be determined by the number that comes before that. So barium hydroxide octahydrate.